In this diagram, let's start from the left. The prompt is locate the reflection of the frog. And we have this photo of the frog, and you can see there is an orange box just on that reflection. And the model's response is that it's located and then in the orange region. In the second example, we are asking the model, please give a brief description of region. And the region is which is in the orange box. And the model's reply is a large dinosaur skeleton. And it's picture perfect. And then if you look at this bottom left, the question is it safe to drive like this? And we have provided the model and image. The model has grounded the red box, the man, the green with mobile phone, and then orange the coffee cup. And the model's response is that it's not advisable. The man is holding a cup in one hand and talking on the phone, which means he's not using both hands on the steering wheel, which is in the blue. This could be a distraction and increases the risk of an accident. How good is that? Then look at the far right example. We have this image and we are asking the model, can you describe this image in detail? And you see that model has replied with a very terse compact response with color coding, that in this image we see a woman because of her hair, and then it has made a box around that woman sitting on a concrete bench, and then there is yellow in the bench. It could be railing or something, and then it is saying working on her laptop. It has also made the box around laptop. She's surrounded by a green bag and a white bicycle that's leaning against the bench. Behind her, there's a large brick building, you see, and a tree. It has even identified the tree. It didn't identify the tree with no leaves, but anyway, all of this has been produced by this model called as Groma. Groma is a multimodal large language model or MLLM with grounded and fine-grained visual perception ability. Beyond holistic image understanding, Groma is adept at region-level tasks such as region captioning and visual grounding. Such capabilities are built upon a localized visual tokenization mechanism where an image is decomposed into regions of interest and subsequently encoded into region tokens. By integrating region tokens into user instructions and model responses, they have seamlessly enabled Chroma to understand user-specified region inputs and ground its textual output to images. Here is another example where it is all happening. Also, to enhance the grounded chat ability of Chroma, they have curated a visually grounded instruction dataset while leveraging the powerful GPT-4 vision and visual prompting techniques. Compared with MLLMs that rely on the language model or external modules for localization, Groma consistently demonstrates superior performances in standard referring and grounded benchmarks. Now, if you look at this diagram, this is the new paradigm of MLLM. So instead of relying on LLMs or external modules for localization, Groma is exploiting the spatial understanding capability of the visual tokenizer. This perceive then understand design also resembles human vision process. So this is the whole conceptual overview of different grounded MLLMs. So for example, in the picture A, you can see that LLM for localization such as Shikra or Cosmos 2 and various other. In the B, we have external modules for localization, and then on the C is a visual tokenizer for tokenized localization, and the third one is the Groma, and you can see how detailed that Groma is. This is the GitHub repo of Groma, and I'll drop the link in video's description. There you can also find out the code, and you would need a good GPU in order to run this. The demo is still not available, so as soon as it is available, I will also show you that. Let's have a look at this framework. So here, Groma is encoding the image into both global image tokens and our local region tokens. Specifically, a general purpose region proposer is introduced to discover regions of interest, followed by a lightweight encoder for region tokenization. By integrating region tokens into user instructions and model responses, Groma unlocks the referring and grounding abilities. And there are a lot of other good things which are happening in this Groma, and I could go on and on. For example, it provides us the balancing computation and input resolution, plus it also decouples design for specialized training, and that is very handy to obtain robust and precise localization capability. And that is why they have pre-trained Groma on large scale detection data. And thanks to its decoupled design of perception and cognition within, they have circumvented the need to involve the LLM during detection pre-training. And that allows, by the way, Groma to benefit from pre-training on millions of bounding box annotations, which is a task that would be really computationally prohibitive for classic MLLMs. And then there is a unified interface for referring and grounding, and the list of Groma's capabilities go on and on. I will drop the link to it in video's description. Let me know what you think. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.